All right, today I'm going to show you how to avoid a common race condition bug when creating JavaScript enhanced forms. So over here on my screen, you can see a very basic HTML form, and when we hit submit, we can see that the browser does a whole page refresh. The form might look something like this, and I'm currently building it in Vue, but that's not going to be very relevant for this conversation. So this technically works fine, but a very common user experience improvement is to take that form submission, intercept the default submit event that reloads the page, and submit the form using JavaScript. Before we do that, I've made a couple changes to the code. Some of it is Vue specific, but the part that I want to focus on is we wait for the page to essentially mount, then we grab the form element and we add an event listener called handle submit, which we'll be focusing on here. So inside the handle submit function, we can grab the form element from the event's current target, and then we can construct a fetch API using the form action, the form method, and the form data in the body. And then very important, we want to call event.preventDefault method to prevent the browser from reloading. So now if we look at the screen and we hit submit, we can see that the page doesn't reload, but we do get that API request in our network tab. Unfortunately, by using JavaScript to prevent the default behavior, we've actually introduced a bug that the browser by default prevents. If we go back to just the plain HTML example, let's see what happens when I smash the submit button a bunch of times really quickly. You'll notice that a bunch of the requests actually get canceled and only the most recent request continues. Now, if we compare that to the JavaScript example, let's see what happens. Well, all of the requests are sent and all of them complete. And here's where we might have introduced a bug, because although each of those requests were sent out in a certain order, they each may take a different amount of time, so they may resolve in a different order than they were initiated. Which means if we add some functionality to the resolution of those requests, we might have some unexpected behavior. So let's see what happens when I create a count variable, and then every time we run the handle submit function, we increment that variable, capture a local version of it to reference later on, and then once the fetch request completes, we can actually log that count to the console. Now, if I go and smash that submit button a bunch of times, we can see that all those requests resolve in different order. And if we look at the console, we can see the order that they were resolved in. Probably not what we had expected. Although the last one did resolve last, the first one resolved after the second, third, and fifth. If we look back at the non-JavaScript functionality, we can see that the browser actually cancels any of the previous requests and only allows the most recent one. So we can actually imitate that behavior using just JavaScript. If we look at the documentation for the fetch API, we can see that it's possible to abort a fetch using an abort controller and the abort signal. And the way that works is like this. We create a new abort controller, and then when we construct our fetch request in the options object as part of the signal property, we pass the controller's signal property, such that when the controller is aborted, it's passed on to the fetch request and the fetch request gets aborted. So we can see as long as I do this in a very quick succession, the fetch request will be aborted when we call the controller's abort method. So we see the request went out and we see the DOM exception that the user aborted a request. So with that in mind, we know that we can create an abort controller and pass the signal to the fetch request that we're going to make, and then later on cancel it. So let's say if a subsequent request is made, we can cancel any previous requests. So we can do that as long as we have a reference to those abort controllers. So there's probably several ways to do this, but I'm just going to showcase one. I'm going to start by creating a weak map called pending forms. This is going to be so I can keep a map of the forms that have been submitted and their abort controllers. Next, when a form is submitted, I also want to create an abort controller to associate with that form. Next, I'll create the abort controller for this form, and I'll tie them together by using the pending forms weak map and using the value of the form, which is this event's current target, and the controller that we just constructed. So this allows us to add the associated form and its abort controller to our weak map, which means earlier in this function, we can actually check for any time that handle submit is called, whether the pending forms map has the current form as a value. And if it does, we know that that is the controller, and we can just execute the controller's abort method. So then the last step here is to pass the abort controller's signal to the fetch method that we've constructed, as well as waiting for that fetch to complete. And when it does, we can go to our pending forms weak map and delete the reference to the current form. So I realized that was kind of a lot to cover, but hopefully it makes sense, and let's see how it actually works. If we go back to our form and smash that submit button a bunch of times, we can see that all of the API requests, except for the most recent, are actually being canceled, which is helpful because that means the functionality tied to that API response is only going to be fired as we expected. So in the console, we do see 6 exceptions, which is actually what we expect because of that abort signal. And then we only see the value 7 printed to the console because, of course, that is the 7th request that was made. Now, if we go slowly, we can see that those requests are printed to the console in the order that we expect. And if we smash the button a bunch of times again, we can see that we never get out of order. We always get incrementing numbers. So just to recap, really anytime you're creating a fetch request, it's probably a good idea to also have an abort controller so that you can cancel it if you need to. But this doesn't actually prevent the user from spamming that submit button a bunch of times, which could cause those requests to still go to your backend and use unnecessary resources. For that, you would probably want to set up some sort of rate limiting solution. But a rate limiter doesn't solve the problem of race conditions on the front end, so it's still a good solution to have on both ends. Well, anyway, that's all I got for you, so I'm going to abort this video and ask you to please leave a comment and a like if you enjoyed it, and I will catch you next time.